thank you. This is the final breakout in this track. So definitely appreciate everyone that's joined throughout the day. And now we're going to talk about the real deal, trust. How do we trust all this stuff that we're seeing, and how do we combat the whole AI equation? And once you can start automating fake data, things get a little scary. And so we're gonna kind of dive deep into this. Feel free to drop in questions in the chat or the Q&A as you listen, and definitely keep the conversation going. And that's it. So I guess with that, I'm the moderator / chaperone for today. So I'll keep an eye on any questions and as we go. So I guess with that, we'll do a round robin with intros, kind of quickly, like what's your background, what org are you with, and we'll kind of dive into the conversation. With you, I would start with you, Matt. I'm just going to go around.
Yeah, so I'm Mat Yarger. I am the head of smart mobility at the IOTA Foundation. I work with cities, transportation organizations, and a number of others in the mobility space on smart cities, smart infrastructure, and smart mobility projects. I have a history in cybersecurity, cyber operations, and digital forensics from the NSA and DC3, and I've been working on Alvarium with most of y'all for the last 1.5 to 2 years. So I'm excited to talk about it and data confidence and trust fabric. So thanks for having me.
Cool. All right, Reed.
Reed Hinkel. I'm a transformation architect for ARM. I work in our channel team. So it means I work with all of our external ecosystem to basically teach and leverage about the different technologies that ARM delivers and the various different collaborations we have. Including the Alvarium effort that we were proud to be one of the initial companies supporting the announcement. So look forward to our discussion today.
All right, great. Steve?
Hey everybody, Steve Todd. I'm a fellow at Dell Technologies with a background building trusted data storage systems for the enterprise with Dell EMC. And lately I've been working with these fine gentlemen on an idea where we can actually measure the confidence in data on the edge as part of Project Alvarium.
Cool. And then Paul?
Hey everybody, Paul O'Neill. I work for Intel and I'm part of our confidential computing group at Intel, passionate about privacy, confidentiality, integrity of data, especially primarily from a cloud perspective. But as our edge starts to creep towards the cloud and the cloudification of the edge, things like Alvarium are becoming super important for all of our futures around data.
Cool. Yeah. So we'll talk about a variety of different elements of trust as we go. But I guess Steve. So we announced, I guess, Alvarium like right before the bottom dropped out last year with COVID, and so we're kind of spinning things up again and whatnot. But maybe we'll start with when we say data confidence fabric. Like, what does that mean in terms of kind of the architecture and how that helps deliver data across networks with confidence?
Yeah, so I like to say that if data is flowing over a data confidence fabric, that means you have a measurable confidence value that travels with it. Sometimes we use the analogy of if the data is a motorcycle, Alvarium is a sidecar, which collects trustworthy information about that data that can roll up into an overall confidence score. So, the value of this on the edge is now applications, especially those that run outside of a data center, they have a fighting chance at understanding how trustworthy the data is. A lot of today's solutions, you'll get a blob of bits and you'll analyze it without knowing how trustworthy it is. But a data confidence fabric really is a game changer, right? You've got a confidence score and some information about how that score was calculated. And that can generate a whole new class of algorithms that actually use trust programmatically.
Yeah, and it's really a layered approach, in terms of various different trust insertion technologies on top of one another. We've seen a lot. I don't think it's a singular answer, I guess, is the equation. It's how you bring all these different technologies together. And we'll dive deeper as we go. So I'll kind of open up to the group is like, what are the different reasons we think that trust fabrics are going to be really important going forward?
I could say I think one of the key reasons I think it's critically important to the industry is that if we're going to be able to monetize the data, you have to understand what the data is and how much you can trust it, which means you need to be able to trust the source of the data. And I think that's where a lot of where the confidential compute efforts that are ongoing are tangential to that is how do you effectively measure the trust of a platform, and then how do you communicate that trust, and then how can you then also, as part of that trust, assure that you're segregating the data so that you can provide it confidentially to whoever is supposed to be the recipient of that data.
Yeah, I've seen so many kind of data science folks, or just folks over the years that are like, well, I don't care where the data comes from. I just want good, clean metadata, and I'll do my analytics. But it's like, know where it's been. How do you extract maximum value from it? And that kind of goes back to the traceability question that was asked in the previous one. Is things are inevitably going to drift over time, and it can really starts in silicon out at the edge. Matt, I guess same question for you. You've been working a lot with IOTA Foundation around the different projects, and how do you facilitate data trust across broad networks, different use cases. I guess tell us about what you see as some of the most important reasons why this matters over time.
So there's a lot of different directions you can take this conversation. You can focus on how do you ensure privacy is being upheld. You can focus on automation of using the data. So if you have a very high level of confidence, you can do more with it more readily, because you're not worried about dirty data going into an algorithm or anything like that and messing up your application. You can have trust inherently in the data and do more. So from the blockchain side, that's where smart contracts get really interesting in automating processes at the edge or in a decentralized network. Once you have that, what's known as Oracle process in our space established, you can have trust in the data, and you can start to automate some of these financial transactions or just transactions in general. And then it also gives a lot of transparency in the data if needed. So when it comes to regulators and policymakers trying to ensure that compliance is being upheld, one of the things that Paul coined really early on was compliance as a service. And I really think that hit the mark really well from a regulatory perspective, because they don't need to own or see everything. They just need to ensure that their necessary policies are being upheld and regulations being adhered to. And with the data confidence fabric, you can provide transparency into the data while still maintaining privacy, which is really important for individuals and businesses.
Yeah, and if you link those together, from a data monetization standpoint, but also privacy, there's something we were talking about in the state of the stack session before this, that everybody's trying to get into the data path. I'm going to own the data. I'm going to monetize the data, but then there's some big challenges with that as well around privacy and data sovereignty and all that. If you travel as a sidecar, as Steve said as an analogy, you could literally monetize data by delivering trusted data without actually seeing the data itself from a privacy standpoint. So there's some interesting things there.
Yeah, it's facilitation as a service instead of ownership and content creation as a service, which I think is much more scalable.
Yeah, there's a value to be extracted there. Steve, what are your thoughts on kind of why does this matter?
So I mentioned that it matters to applications in real time already, right? If they want to make real-time business decisions, now they can do so with confidence. But since a lot of this information, the sidecar, can actually be a ledger, that trust information and that confidence score, that can hang around for a long time and help you with regulatory audits, right? Everyone's scared of getting audited on the edge. What did you do with your data, right? A lot of companies are going to throw up their hands and say, there's so much data, I don't know where it went. But with this trust fabric concept, you actually have not only something you can use in real time, but something you can use historically to say, hey, here's exactly what I did with the data, right? I handled it in the context of a secure enclave. It was born next to a trusted platform module on this machine, right? And that proves that you handle the data with care. So instead of paying big fines, you can satisfy an audit quickly and electronically. So I think that's another big value of the technology.
Yeah, you see sometimes where people are like, "Oh, I caught you on video, and we're using this video in some legal proceedings." Like, "Oh no, that video was manipulated." Well, actually, no. And there's so there's kind of, from a monetization standpoint, compliance, GDPR, any of the new regulations, is most people know, like if someone says, "Just kidding, I want my privacy back," you have to go, right to be forgotten. You got to go find where all that data went. That's a little tricky. In theory, if you do it right, you could click a button and it just, everything disappears, through the fabric. So, Paul, what about your thoughts on kind of why this matters? And actually, maybe kind of segue from that into what you're doing with confidential computing, along with Reed as well, and a bunch of folks in the out there in the landscape.
Yeah, thanks, Jason. I think confidential computing itself is a pretty new concept, I guess, in its most simplest terms. Protects data in use, right? There's lots of technologies that allow data to be protected at rest and in flight, but allowing data to be computed on in a confidential manner, and thus preserving privacy in areas like the public cloud has opened up lots of new possibilities with data, particularly in highly regulated industries, healthcare, financial services, et cetera, et cetera. Now, on the back of this, we're starting to see organizations allowing third parties to access sensitive data sets, or pooling sensitive data sets together to gain, better insights, or potentially monetize their data, operational efficiencies, or even building sort of privacy preserving federated models for data collaboration. And they can do this without contracts per se, right? Using, confidential computing as a cryptographic intermediary, if you will. Machine learning and artificial intelligence, as we mentioned earlier, are dominating the confidential computing space, and really this is its raison d'etre. And they're going to need more and more access to private and trusted data sets, right? Confidential computing can use attestation techniques to sort of aid the evaluation of trust techniques in the cloud. But in many ways, this new paradigm is sort of working with data sets that are coming from trusted sources. All of our companies here are building, things in the cloud that allow us to build trust frameworks, whether they're cabling or storage systems or whatever, right? So these mechanisms can allow control over what can happen with these data sets. But as we start to think about computing at the edge and sort of the overall cloudification of the edge, can we really have assurance on the source of the data? And the answer is kind of no, right? What about privacy preserving edge using confidential computing techniques, for example, or data sovereignty? We don't need trust frameworks in the cloud. So confidential computing itself is running well and growing quite nicely in the cloud. The edge remains a disrupted environment for data sources. All of our companies here see huge demand for more and more compute closer to where the data is being created and consumed, driving a new wave of sort of multi-function compute hungry devices, if you will. AI is fundamental. It's going to become pervasive in all applications and shaping the future of entire industries. Listening to some of the things on oil and gas, for example, earlier on, quite impressive, right? But AI can turn data from a burden, and a lot of people are seeing data as a burden, into an opportunity. And at Intel, we feel that artificial intelligence and AI will be the defining workloads of the next decade, driving disruption across, the whole data-centric landscape. But like confidential computing in the cloud, AI and machine learning workloads at the edge need to be fed with data. But unlike the cloud, the sources of data are really unknown and generated on multiple different devices. And data really is only valuable insofar as you can trust it. And that's always been the premise of when we got together around Alvarium. If you can't talk, or if you can't be confident about the origin of its contents, are you going to take a risk on it? The answer is no. That's a big problem for businesses eyeing the sort of 5G future and developing strategies for monetizing data generated at the edge, or insights that can get into Industry 4.0, et cetera, et cetera. And this is where data confidence fabrics come into play by helping organizations disrupt today's edge business model by quantifying the privacy, accuracy, and security of data flowing into the networks using trust fabrics, potentially allowing for a more intelligent edge, as we call it, promoting incentivized collaboration. So the concept of everybody bringing data together. Combining confidential computing techniques like attestation that our company is working hard on, as is Reed's, trusted execution environments, again the same, and encryption into these fabrics opens up the ability for machine learning and AI to make decisions on data processed right where the data is generated. To me, that's a powerful combination. So, for example, one of the leading requirements for edge networking is privacy preserving predictive analytics. This requires very small decision latencies that are different to data processed in the cloud. This processing typically occurs outside the boundaries of a data center or data center firewalls and beyond the reach of these dedicated data center security teams, potentially, creating a new data trust issue. So, for example, we see some of the large car manufacturers in Europe trying to bring data from machines that they don't necessarily own that could be competing in a machine as a service type scenario. Processing trustworthy data means creating an agreed upon source of truth in a complex operating environment. That's hard. This depends upon sort of data providers and data consumers agreeing on the provenance of the information and the policies governing the information. This requires a digital supply chain audit capability that Steve mentioned earlier on, where participants understand and agree on what happened, when, and why without breaking compliance and privacy rules. Compliance as a service. Data will be combined with other data sets to allow multi-party computation to happen, but the provenance of the original data will need to be always preserved or watermarked, again, as Steve mentioned earlier on, if you will, to ensure compliance. So measuring trust at the edge, where typical usage involves multiple parties and with and without pre-existing business relationships, which is an important point here, is something that's never been done before. Here in Europe, there's large projects like Gaia X and Catena X, for example, that are really going to have to solve this problem. So as the confidential computing consortium under the Linux Foundation becomes stronger, a lot of the focus is going to turn to edge computing, and it's inevitable, in my opinion, that the confidential computing consortium and Project Alvarium under the LF Edge will meet to help provide methodologies to ensure privacy, confidential computing spaces, and integrity, even as far as provable functions. So I think the combination of the two is immensely powerful.
Yeah, cool. Yeah, and just to clarify for folks that are unfamiliar with confidential computing as a topic, it's Paul, you alluded to this, but it's making sure that in flight, as things are being processed, that data is encrypted and protected. So people at all points, we've had disk encryption, we've had encryption across the wire in motion, but it's kind of rounding that last out, and that last little bit out. And I know, as you mentioned, Reed, you're very involved in it, and wanted to get your thoughts on, how are you guys approaching, both confidential computing and kind of trust in general within the ARM ecosystem?
Okay, so trust in general. I mean, we have such a wide diversity of devices that are powered by ARM processing technology. Everything from the smallest microcontroller up to cloud infrastructure platforms. So we have a pretty wide range of architectures, from an actual silicon architecture that need to be protected, and a pretty wide array of different solutions for how we can deliver that, given the kind of device. So what we're taking is really how do we basically set the baseline, since we work in a very diverse set of deployments, through the various different licensees of ARM. Obviously ARM doesn't make and manufacture and deliver the end technology, but we do create the IP that it's built from. So from an architectural level, our aim is to raise the bar and to create a way to measure that bar for the actual security, which would be the baseline, the root of trust security, and then also the secure and operating environments. So things like trust zone and other elements of that are available on various different versions of the ARM architecture. How do we set that? So we have a couple of different things that we've done. So ARM worked with industry partners to create the platform security architecture and a certification scheme around that helps us identify the key elements of the root of trust, and then be able to measure that root of trust. So we have a complete certification scheme around that. So that kind of becomes the basis for a lot of the trust technology, or the trust insertion that we're able to orchestrate through our ecosystem. So I think that's the beginning point, and what we want is that baseline to be something that's measurable and something that can be relied upon. And so you'll see if you go to the psacertified.org, it's a entity that's not part of ARM, and actually go through how that is actually done, and how evaluation goes on, and then ultimately how it's attested to, which what we created from the very beginning is how do we do that even on the smallest microcontroller. So we've worked on attestation methods that can be used even on the smallest microcontroller. All of that extends all the way up to the sorts of classes of devices that Paul talked about. So up to infrastructure edge devices, infrastructure edge, and then also into servers. That's really more the purview of the CCA, the ARM Confidential Compute architecture. That I'll drop a link in the chat if you haven't seen it. This is something we announced just a very few weeks ago. So from an ARM perspective, it's a continuum. How do we create the baseline across that continuum, and then advance that and move that ball forward with the entire industry and ecosystem around it.
Yeah, great.
And just to layer on that, sorry, Jason, the concept of, ARM-based devices with trust zone, attesting to Intel-based data center devices is hugely powerful. And, think of, secure channels and attestation of data between those two devices and feeding that into a trust fabric, hugely valuable, concept for provenance at the edge.
Yeah. Cool. Yeah. So also we've mentioned Alvarium a couple times. So just so it's clear for folks that haven't heard of the effort that we're spinning up as a community. If you go to alvarium.org, there's a video there that kind of describes the concept of trust fabrics. We had worked on that together, and there's a number of other companies that have been involved, and we're growing as a community. And Matt, you came in early, so Steve, we had worked together obviously at Dell, and started bringing folks in as we were building up the concept. Matt, we brought you guys in, even though a trust fabric is not one set of technologies that are fixed. It's more of a loosely coupled grouping of technologies, from silicon root of trust up through open API stacks, trusted operating systems, confidential computing, ledger, these layerings of technologies. What was it like? So you guys kind of came in and helped build out that first prototype with Dell and Intel and others, like early on. Like what was it like kind of working with the team and kind of as you collaborated?
It was really interesting. We learned a lot as a pretty new technology. So we got to see some of the limitations of the technology, of course, and where things like latency really are going to come into play. But we really got to understand a lot of the benefits of our inherent structure as a protocol when it comes to data versus value, structuring data, increasing anonymity with decentralized networks and things of that nature. So we've been able to utilize the opportunity to really accelerate a lot of what we're doing around decentralizing data and the security and privacy around that. And that's come into a number of different conversations in our ecosystem, whether it's a bunch of different pilots we're doing with European Union and Commission funding, or whether it's around climate data, like what we have from the Canadian government. There's a lot of interest in utilizing this when there's a reliable structure and there's verifiable provenance for the data. And with us as a young organization working with a lot of y'all, or with all of y'all, it's been a really great opportunity for us to accelerate our innovation. Great.
Well, and so I see, and Matt, you responded as well, but this is a really good question. We've definitely talked about this from Shan, is so the gist is, by injecting trust in data, there's inherently a tax in terms of compute or time in terms of latency. So if you do that, is it still real time data? And so, Steve, maybe I'll ask you, like, what are some of the different considerations and different ways that you can inject trust into data and that measurable confidence while still making sure that there's not an overtax on compute power and time itself.
Yeah, so we learned a little bit about that with the integration with IOTA. When you think about deploying a data confidence fabric, if you're writing sidecar information in a synchronous way, you have to wait until that ledger or whatever technology it is finished storing it. Anytime you introduce a new technology like this, you'll start to see some performance ramifications, right, of doing something in the data path. But over time, we always optimize, right? And we think of other ways to perhaps persist that sidecar information immediately and then stage it out to a ledger at a later date, right? So there's always that delay, which may result in slower adoption for some specific use cases, but we'll find a way to make it fast, right? As we try and satisfy more use cases.
Yeah, and one of the reasons why we call it a fabric is because you start seeing these weavings of different fabrics across ecosystems starting to intersect. And as that happens, you start seeing boundary conditions being normalized. It's just like, circle of trust. Generally, it's your family that's closest to your circle of trust, maybe not your crazy Uncle Larry or whatever, but, and you get new friends in your circle and you build trust, and it kind of tends to normalize. But, the one of the keys I remember, we've talked about is you don't have to inject trust necessarily at every point within your fabric. You can do it at the boundary conditions between yours and someone else. So, it just depends on the use case and the what you're trying to do. But other thoughts on kind of this notion of, when and where you inject trust into data and how do you navigate some of the pitfalls with it?
Well, if you look at the group of vendors that have been coming together with Alvarium so far, right? You have Reed and Paul's team showing up, and so at the silicon level, it's an obvious place to inject trust. Jason, as we talk about ZEDEDA as a platform, right? Running on edge devices, your operating system is a place that you can inject trust. We've had companies like VMware, also virtualization technology. When you look at the network, right, moving the data from one hop to another, we've had Juniper show up, right? And they've got trusted technologies that could be inserted at that point in the stack. So, I think now what we're looking for is as we start to build the team of plumbers, right, that handle the data as it moves through the system. Now we need some application vendors to really have an end-to-end use case where you can see it from data creation to data processing, all the vendors working together, right? So that's where I'm hoping the community goes in the months ahead.
Yeah, I agree, Stephen. I think as we've done with the Confidential Computing Consortium, we're really laying out the plumbing, if you will, for an ecosystem to come along and extract the value out of it. And I think it's the same method here. We need that ecosystem to come extract the value from the plumbing as you describe it.
I think one of the things I would say, as Paul mentioned, it's critically important. The ecosystem opportunity here is immense because something this important actually is one that can actually drive more overlap between the individual ecosystems that exist out there, because it's such an important topic in terms of driving even the commercial aspects of what drive our business, especially B2B business. So I think this is an opportunity. I think everyone's coming in with obviously they have the position, things that they've developed from a technology point of view, but I think we're seeing a lot of genuine collaboration early on how to solve these things, because they do require a much different ecosystem than existed before. And this is true of almost anything to do with security, anything built upon security today. The ecosystem is much different than it was, and there can be no islands, which is really good, because from us calling it a fabric, I think it is an inviting term to basically invite a pretty wide ecosystem of partners into solving this particular problem space.
Yeah. Yeah. Another question that came in is, so is a trust model dependent on the application, or is there more kind of universal or generic trust model? Like does trust within a factory apply to data that then moves over into, say, a smart city or into the home use case? I'll open that up to the group.
Yeah, I'll take a first shot at that one, Jason. In terms of assigning a score to data, right? I don't really think that there's going to be one way that you calculate scores for this data that's going to apply for all use cases and all applications. So one of the things we're thinking about is the score may be assigned at the very end of the process by the application that's consuming it, right? The application that's consuming it can look at the annotations or the lineage of where the data has been and decide what factors are most important to me for a score. So I think, I believe that the Alvarium framework will be very flexible in that regard, in terms of letting the application define what confidence is and what factors are more trustworthy than others.
Matt, what are your thoughts?
Yeah, I think one of the things we're seeing from the planning and integration of this kind of concept with climate data is there's existing standards and methodologies that haven't quite been digitized. Every industry has them to standardize how they interoperate and how the devices already interoperate. And when it comes to building out the trust models, I think there's going to be an underlanding privacy and security trust model that's generic, that goes across industries. But then there's going to be a very specific set of attributes or data attributes that come on top of that generic model that are specific towards that use case. So electric utility companies are going to have a very different definition of trust than a climate data or climate exchange will. And there's going to be certain requirements that they're going to have to verify based on the devices that operate in the ecosystem for them to trust the data and process it accordingly.
Yeah, I think that's a key concept. Is the concept of trust fabric is agnostic to kind of specific data semantics and what that are relevant in a certain industry. So I think there's a little bit of both. The applications Steve, that you mentioned is that are kind of decide what elements are required and how do you assemble it, but then also and apply that semantics for a given industry. But there's also an element where this concept is horizontal in nature. Other thoughts on kind of that balance between application specific and horizontal?
So I think this is where it's become interesting, and when we evaluate and look at how to do architectures today, it used to be what do we need to do to deliver a function or functionality? That's what we thought about. We thought about what's the end product need to look like. Well, in this case, if you think about data, there is an end product there, and there is an expectation for that data. The problem is we haven't communicated to the people to the consumer of that, to actually find out exactly what they want and what they expect. And I think that's really, when we started using the term relying party, in this perspective, that's really, the people that are, if we want to monetize this, then the relying party has a lot to say about what factors go into establishing how I trust the data. So it is exactly as Steve said. It could be a whole array of different considerations based on who the relying party is. So I think we're going to have to, as with any technology, I think what we have to really expect is that we have to map what we can deliver from a technology point of view to what real life use cases and real life usage models are. And in this case, again, I like the term fabric, because I don't think we can make it it needs to be very non-regimented to really be effective.
Yeah, I think that's a key we've talked about, I think, all day is the need for loosely coupled architectures, API driven. There is no single answer. I mean, we need the right tools, but how you assemble those tools based on different use cases and markets and all that is going to vary. and it's inherently fragmented. But we do need also more holistic system level tools, which is the concept of these fabrics that we're all evolving. One more kind of wild card question, then we'll sort of summarize. But I talk with folks about this all the time, and whose responsibility is it to manage privacy between the corporation and the consumer? Kind of throw that out to the group. What falls where?
I think ultimately the responsibility is upon the consumer of any device. The problem is what they don't know will hurt them.
Yeah. And
so what they don't do is they don't ask enough about the quality of the device that they're buying, or the who's going to stand up behind the warranty. They will read a lot of things but not really do much investigation. And I think that's really the unique opportunity we have here from building this compound trust example. Is you should be able to have measurable elements within that can be represented as having some level of confidence that you can attach to it. So I think that's really the unique piece that we're able to deliver here, is that there is something measurable here. And I hope we're transparent in how we actually communicate that, so that the people, the relying parties, the people who are relying on this trusted data are, can have the confidence. They, completely upfront, they'll understand what they're getting.
I think you're wandering into the world of data sovereignty, Jason, as well, which is a whole webinar on its own, right? I mean, as we kind of wander or stumble into the challenge of the data decade, the next decade, really, data is going to represent the lifeblood of every organization. The CDO, the Chief Data Officer, is going to replace the CFO as the keeper of the kingdom. So, how we solve the problem of data sovereignty is going to be an interesting one. I mentioned Gaia X earlier on. Mat's very involved in Gaia X. We're starting to see things happen with Catena X, where people are really building things around data province or data sovereignty being the center of everything. And this is a really interesting switch. It's a real European thing right now, but along the premise, if you don't pay for it, then you are the product, right? So, so I think that's a whole super interesting area that I think trust fabrics, confidential computing can really help with data sovereignty as well.
Yeah. Any other thoughts on kind of who owns it, consumer versus corporation, the whole question of privacy?
Well, I think it kind of comes down to contextualizing data from our perspective, because some kinds of data, like you can have one device that produces multiple types of data that are relevant for different type of applications. So a vehicle can produce environmental data, it can produce some contextual data, it can have product data on the vehicle itself, but then there's also different data points that can be classified as PII. So once you get down to the point where you can start to contextualize the data at a very granular level, data sovereignty becomes a much more flexible question, because individuals can have a little bit more say in what kind of data they're comfortable sharing, what kind of data they're not. And organizations don't have to pull all of the data like we're seeing a lot of times today. They can pull the data that's actually relevant to them without everything else that's not necessarily as relevant for their application.
Which is hard.
Yeah.
It's very hard.
So then it's up to, kind of us, a lot of us, and then of course there's application providers as well, which is super important, and people that have the domain knowledge. But it's up to the corporation to provide the necessary tools, and then it's up to the consumer to leverage those tools and decide based on policy where do I feel comfortable of my privacy versus value received.
And you mentioned GDPR, and I mentioned machine learning a lot and AI a lot. AI, GDPR, it's hell waiting to break loose, right? But the reason that confidential computing and trust fabrics are so important is that as you look at things like, let's take an example, video from autonomous vehicles in Germany, right? PII, GDPR splashed all over it, right? So what do we do with it? Corporations take it, they obfuscate, they pseudonymize, I can't pronounce that word, they anonymize the data, right? They de-identify it. It's a hugely costly process to do that. That's why, working on encrypted data is so efficient. It gets models trained quicker, better. It drives brilliant silicon sales, right? For us, fantastic, right? So, but you're getting this efficiency working on raw data. Models are better, right? So encrypt everything and work on encrypted data, and everything's cool. You don't have to worry about GDPR or stuff like that. Right? But that is, in all seriousness, that is a hugely emerging space, and a big way of bringing confidential computing, trust fabrics, and all that framework into play. Look at efficiencies in that type of area. Big opportunities.
Oh, yeah, no, this is a huge conversation, and yeah, drop the privacy bomb at the end, but that is a whole conversation in its own right. And like I said up front, it's the automation of things with AI is creating a whole other ball game coming forward. So I'm sure we'll have many conversations of these things to come. Steve, I'll leave kind of closing thoughts with you, just and you also maybe mention a bit of kind of what's next with Alvarium as we work on it, and then we'll kind of head over to the main stage for the closing.
Sure, thanks. I would say, number one, companies that are on the call here, please show up and participate, right? So we can build a bigger ecosystem. Jason, we talked about probably the biggest value at the beginning is compliance, right? Companies that implement data confidence fabric can reduce their risk of fines through this technology. They can improve their OPEX and their operating costs, right, by making better decisions on the edge. But when you think about what's next, you're talking about monetization, right? If you're building up this sidecar of trustworthy information about the data, it'll be easier to get a bigger price tag for it. Or as you like to say, Jason, people that you don't know will just start writing you checks for the data.
Mm-hmm. Send it off to complete strangers in the ether. The ultimate potential is to sell data to people you don't even know. Data services and resources to folks you don't even know. So any real quick last closing thoughts? We need to head over here in 1 minute.
Thank you for your time, everyone.
Yeah, I really appreciate you guys being on, and yeah, keep an eye out. If you're listening in, we've got a working group within the Alvarium project that's emerging in Linux Foundation. There's definitely a lot of other great efforts around trust out there in this space, and you reach out to any one of us if you want to kind of learn more, and there'll be some more public info here coming soon. But yeah, really appreciate your guys' time, and we'll continue to hammer away at this pretty important topic.